Okay, so technically I think I'm live. So whoever is joined, just confirm me whether I'm live or not. Okay. So if I'm live, then only I just start with keep this away and just tell me. Okay, just tell me as fast as possible. I'm also checking. I'm also checking whether I'm live or not. Okay, it is showing that there's one person who is watching this. So basically, okay. So I'm live, right? Am I perfectly audible and clear and visible? Okay. Also confirm that. Okay. So if everything is confirmed, then only I'll start with the video. So in this video, I'm going to discuss the GFG. Okay, today's GFG thing. Okay. So I'll just pin this message. Okay. So let's. There were some comments out there. Okay, before that. Hi, where's the code? People are like more. People are thinking more about the code, huh? So I'll just pin this message. Okay. So if you're new to this channel, just give me a subscribe and just like this video because that will be really helpful for me. Okay, so let's start with the video. Sorry, not this. So if we go for the first question, the first question is winner team. Okay, so what the question tells us is basically you're watching an exciting match between three teams: Team X, Team Y, and Team Z, or Z as you may call it. Okay, now each team consists of n players, and for each player they have a specific power value. And what happens is basically in each round, the first available player plays. Okay, for the three teams, and the player with the greatest power in each round wins the match and proceeds to the next round, while the two losing players will be disqualified and eliminated for the further rounds. Okay, and after each round, the winner will compete against the next available players. Okay, and this goes on until and unless there is only one team which is left with some players, or let's say even at least one player also. Okay, so if you look at it, so I'll just, why can't I even copy it? Okay, 753481629. 753481629. 481 and 629. So these are the values of the players in X, Y, and Z respectively. Okay, now what happens, first of all, this 7, this 4, and this 6 plays together. Now remember one thing, it was also given in the question that if there is a tie between the powers, in that case the player who is at a higher position, I mean not higher position, which is in a alphabetically lower team, that is, if there is a tie between X and Z, then X wins. If there's a tie between X and Y, X wins. But if there's a tie between Y and Z, then Y wins. Okay, so if there is a tie, so the first tiebreaker will be broken by team X, then the next tiebreaker will be broken by team Y, then team Z. So basically team Z doesn't break any tiebreaker. Okay, if you look into it. So basically let me just use the red color. Am I audible though? Because I don't find the comment section is interactive. Okay. Audible though, because I don't find it. Let me just do one thing. Let me just go to the Discord and put the link of that. Okay, so GFG, where is GFG? GFG post contest. Okay, so let's hope that there will be like people coming in. So till that, so as I was telling you, this red thing. So first of all, these three players play. Okay, these three players play, and if these three players are playing, basically this 4 and 6 are the weakest, so they get disqualified, and 7 is still standing. Now 7, 8, and 2 plays. Now 8 is the strongest, so 7 and 2 gets disqualified. Now 5, 8, and 9 plays. Okay. Now 8 is, I mean, now 9 is the strongest, right? So 8 and 5 disqualifies. Now 3, 1, and 9 plays. And 3 and 1 are the weakest, so they both disqualifies. So basically the winner is from group Z. Okay. So if the winner is from group X, we return 0. If it is from group Y, we return 1. And if it is from Z, we return 2. Now if we notice one thing, the trick of the question that it was demanding us, we don't need to, like, whatever I was telling about the simulation of this whole process, you don't need to compute the whole simulation, because we know one thing, that if the player with the maximum power is in some team, then that team will only win. Okay, because that player will like outthrow all other players from other teams, right? I think there was a lag on my side. Just wait, I just fix it. Okay, now it is fixed. So basically what happens is, you know one thing, that this for like whoever is having the maximum power is going to win no matter what, because throughout all the contest that player will be unbeaten. Now if the maximum power is in Z, then we can say that Z wins, right? But what if the maximum power was also in X as well as Z? So in that case, X will win. Why? Because X is alphabetically lower than Z. And it was told that if there is a tie, then alphabetically lower one will win. Okay. So basically, the condition is like this. For X, you have to find what is the maximum element. For Y, you have to find what is the maximum element. Okay. And for Z also, you have to find what is the maximum element. Now, if the maximum element of X is greater than equal to that of Y and greater than equal to that of Z, then we can say that X will be a winner. Because if it is equal, even if it is equal, or even if it is greater, he will be the winner. For Y, if guys, can you just tell me, like, is there any glitch from my side? Because not much people are watching. Anyways, people who are watching though, I'll just tell you, like, just like the video and subscribe my channel if you're new, because that will be helpful for me. I was not expecting this low watching right now. Okay, so there's like 3 people watching, so I was not expecting that low. And guys, whoever is watching, just be responsive. Just be responsive in the live chat. Okay, so it will be better for me. Like, at least tell a hi or something like that. So I'll just assume that yeah, you were watching it. Okay, so that's it, nothing more. Now based on that, we can say that if the maximum of X is greater than equal to the maximum of this and the maximum of this, then X is a clear winner, right? X is a clear winner. And if X is not the winner, by Q by bro, what happened though? He left the chat. Okay, doesn't matter much, who cares? No, just kidding, man. I don't know why I say bye. Because I he left the chat. Okay, I don't know what the heck is happening. So anyways, now if now we can see that whether X is going to satisfy or not. Okay, now we are going to check for Y. Okay, when will Y satisfy? If Y it is greater than equal to that of Z, then only Y satisfies. Now if that also doesn't happen, that is Y also not satisfying, then we can say that clearly Z is the winner. Okay, so let's go with the code quickly. I'll go with the code quickly. So I'm having n and the vectors x, y, z, and m1 is basically the maximum of x, m2 is basically the maximum of y, and m3 for z. Okay, and for all the elements I'm going to compute the maximum, okay, for x, y, and z. And after done with that, I'm going to check for the first condition I was telling, whether x wins or y wins or z wins. Okay, now this condition was actually not required though. This condition was not required. We could have gone for this directly also. So basically, if you notice this, so this is what is the condition. So that is m1 is greater than equal to both m2 and m3, then return 0. If m2 is greater than equal to m3, then return 1. Otherwise, you can return 2. That is z wins. Okay. So I hope this is clear for you guys. I'll just move on to the next code. Like 3 people are watching. Just guys, just be interactive, and like I think it will be like not that logical if I ask you to subscribe, because you may feel that. So I'll just tell you that if you find my content to be good, then only subscribe. Okay, otherwise don't subscribe. It's okay. Okay, so let's go on for the next question, that is operation on numbers. So you're given two positive integers a and b. Your goal is to make the values of a and b equal by performing a series of operation on b. You're allowed to perform only two types of operations on b. That is, if b is a perfect square, you can adjust it with the square root of b, or you can decrease 1 from b. Okay, you have to find what is the minimum number of operations that is required to make b equal to a. So let's say we have two values. Okay, we have two values, a and b. Now I have to check whether I can square this out or not. Okay, and even if I can square this out, whether the square root is going to be lesser than a or greater than equal to a. Because if it is lesser than a, so it will be like logic is to square it out, right? It will very much out of logic. Because if it is lesser than that, then you can see one thing, that basically no matter whichever operation we are performing, whether we are square rooting it or whether we are decreasing it by 1, basically b is decreasing, right? But if it is decreasing more than a, then it will be an invalid thing. Okay, so we only square root it if it is greater than equal to a. Okay, if the square root is greater than equal to a. Now what if b is not a perfect square? So in that case, we know one thing, that we can make it a perfect square by applying the operations -1, right, some number of times, and after we are done with it, then we can perform the square root. But if we are computing the square root of b in like long, okay, in long, like long data type, if you're computing the square root of b in long data type, so in that case we know that it is going to give us the square root of the nearest perfect square which is less than b, okay, less than equal to b. So basically if I get the square root of b, okay, so whatever b is basically, so if I make sqrt L, remember to write L, okay, because we are doing it for only long. So if we make it square root of this b, so it will be basically the square root of the nearest element, right? Because we can't square this, because this is not a perfect square, right? We can't square this. So basically this is what we are getting. Okay, now if we know that we can, if the square root of b, it is greater than equal to a, okay, then only we can say one thing, that it is a valid thing. Okay, otherwise it is not valid, because if it is lesser than a, so it's like it's of no use, right? It's of no use. Why is the comment section so like too cool now? Like it's too cold. People are not that interactive though. Guys, be interactive. So basically we can do this. Okay, now if we are going to do this, we know one thing, that before that, in order to make this, we'll need one operation, and in order to get from B to this element, that is the square root of L of B whole squared. Okay, this is this element. Okay, so we'll need B minus this operations, right? So we can take B minus this operations. Too much noise, man. Why is this video like not that interactive, man? I'm just not getting it though. People are there in the like lobby. People are watching it. Just be kind of interactive so that I can like, it becomes very boring to explain something. I can explain this thing like very quickly and then you will not understand it. So just be interactive. So basically, if we go from B minus square root of B whole squared, so this is the number of -1 operations that we need to perform, plus 1. Okay, plus 1, that is how many, that is this operation, that is squaring this. No, see, there is one person here, man. You may say that there is one person here, but from my end, like the YouTube part, it doesn't get updated that easily. Okay, so from my end, it was showing 3 people. Okay, so it is one person 2 minutes back or something like that. Okay, 2 seconds back, something like that. Anyways, maybe there is only one person though. I don't know. Okay, so basically, this is, and the one person is you, so you just be interactive. Okay. So this is how the number of operations that we need to perform, -1, and this plus 1 is basically the square root. Okay, square root sqrt. So I think it will be better if I explain you with an example. So that is, let's take this 5 and 2. Okay, let's take this example 5 and 2. Yeah, I am just keeping explaining. I mean, I'll just keep explaining. Okay, so let's say we have got 5 and 2. Now if we have like the square root of 5, let me just understand this question. I got theory on it. Okay, I get it. So if we want to make this 5, okay, so if we get the square root of 5, that is basically 2 only, right? It is 2. Why is it 2? Because 5 is not a perfect square, but if you go on till if you go on reducing it, so the first perfect square that you are going to get is basically 2 squared, that is 4. Okay, I hope this is clear. So what are the steps basically? So I'm just going for the steps. Okay, now see, first I have to find out till how many operations do we perform -1. That is going to be the square root of L. I mean square root of 5. Okay, so what is the square root of 5? It is 2 whole squared. That whole squared. Let me write it like this. It is going to be square root of 5 whole squared. Now remember one thing, that square root of 5 we are going to treat it as square root of sqrtl. Okay, we are going to treat it as sqrtl, that is the truncated portion excluding the decimal places. So that makes it 2 squared, right, which is 4. So basically 4 is the number that we have to attain by giving -1. Okay, by taking -1. So how many -1s do we have to put on 5 so that it becomes 4? It is basically 1 only, because 5 minus 1 is 4. Okay, and then from this 4 we are going to apply the square root, which makes it 2. Okay, there is 2. So basically we are performing 1 and 2 operations. Okay, Now how we are going to calculate it? We are going to calculate it using this formula. Okay, this formula. So what is this formula? B minus SQRTL B whole squared. This is going to give us the number of -1 operations, okay, plus 1. So this 1 is basically the square root operation, and this is basically the -1 operations, okay, and we have to continue doing it until and unless we find that the square root of L, I mean the square root of B, okay, the square root of B, like till the square root of B is greater than equal to A, we can do this, okay, we can do this, perform this. And if it is lesser than A, in that case we have to only reach from B to A by operations -1 only, solely by -1, okay. So that is B minus A. That is B minus A, okay. So it will be better if I explain you with the code only. So for the time being, I'll just put this chat over here, okay. So what I'm doing is I'm taking the answer as 0 initially, and remember one thing, there was a condition of -1 also, okay, there was a condition of -1 also, that is if it is impossible, if it is not possible to make B equal to A, then return -1. You see where you went wrong? Where did you go wrong? I think you went wrong, like you were calculating -1 operations individually, right? I think you were calculating -1 operations individually. That's the point where you went wrong. So basically, if B is lesser than A, then we can say that we can return -1. Otherwise, even if B is greater than equal to A, we can always reduce B to A. By just applying -1 also, we can make B equal to A if B is greater than equal to A, right? Apart from that, while B greater than A, you are going to perform, you're going to first check whether square, man, yeah, it takes too much time. So basically, if you are going to square root and check if it is greater than equal to A, because if it is not greater than equal to A, so we can just say B minus A, that is getting all the -1 operations, because we don't need anything else. After that, we can just simply break it out. But if it is so, then we have to consider answer plus equal to long int B minus long int, yeah, West Bengal, how do you know? B plus 1 LL, okay. So this is the operation that I have already discussed, that is this thing, this value, okay, this thing. So this is what we have done, and then we have to like update the value of B as square root of B, okay. We are also updating the value of B, but there is one condition, one exceptional case. Same here, okay. So you're also from West Bengal, that's nice. So are you from Kolkata or like in general West Bengal? Now basically what we do in this is, too much noise, I don't know whether you guys can hear it or not. Can you guys, you can hear it also? Like in general West Bengal. Yeah, it is coming, like the this is also there. Okay, Shobhadra, just do one thing, just if you're new to my channel, I'll just tell you to subscribe, okay. No political aspects, okay? No political aspects. I won't go into that. Yeah, so basically it is all over West Bengal. Okay, I get it. Okay, so what happens is basically if you're having this political aspects, man. Okay, so basically there's one exceptional case, that is what if the value of b, let's say the value of b is 2 and the value of a is 1. So you may, like, the square root thing walks over here. So what you will do is you can go for the square root and make it 1, and then you can, I mean not the square root, yeah, you can subtract -1 from here, and then from 1 to 1 you can also perform a square root, right? That is this +1 that we were doing, right? That this thing that we were doing. But this won't be necessary if the value of b is now 1, right? Because the square root of 1 is 1. So basically if we are going to apply a square root on 1, so the 1 remains 1. So we don't need to perform any operation on that, right? Because we have attained it. We have attained the what a is. So that is the reason I have got something over here, that is inside this I am having that if square root of b, if it is equal to 1 ll, then we just need to subtract it. We don't need to perform the square root. Okay, so that is it. So I hope this is clear. If this is clear, I just go to the next question. Okay, just tell me. I think only Saubhatra is watching this. Oh, okay, no, they're showing me there are 3 people watching it. So can you confirm, Saubhatra, whether 3 people are watching it or not? Okay, now it is showing that there are 2 people watching it. 3, 2, so it's getting like fluctuating over there. Okay, so you told that you're from Barakpur, right? Yeah, that's clear. So now we are going to go through exotic subsequences problem. Okay, now there is 2. Yeah, now there is 2 again, exactly as I was telling you. Okay, so it's fluctuating basically. You're given a, so basically, you know what, Saubhatra happens? Saubhatra, do you know what happens basically? Like, just me now. Can't help, man. People, you know why people come and like leave the chat? Because they feel that they don't have the time to wait and understand what the problem is all about. Okay, understand how to solve the problem. They just need the code. Like if you check this, Saubhatra, you can see this. How can I remove this? No, I won't remove that. So see one thing over here. There is a person who, like, okay, this high is okay. So some person is like, where are the code? He is directly like, where are the code? And this person is like question mark. Okay. So people come here just for the code. Okay, just for the code they come here. See, he wrote code. Okay. So people come here just for the code, I guess. So basically that's the reason why they are leaving. Okay, but I will prefer that if you're coming here for the code, then don't watch the video. I don't like, it's okay, you don't have to watch the video, because I'm explaining you something which is going to benefit you at a later future. Okay, so basically let's go to the next question. Copy paste gang. This is the copy paste gang. So you're given a string s consisting of n lowercase alphabets. You have to find the total number of exotic subsequences of the string. Okay, now what is the exotic subsequence? The exotic subsequence is a subsequence where the characters of the string or let's say of the subsequence are in ascending order, not strictly ascending order but ascending order. Okay, so that is the subsequence. Let me write subsequence. The ith value of subsequence is greater than equal to the I minus 1th value of that. Okay, so this is what basically the exotic subsequence means. You can check for the definition also. So you have to find what is the number of exotic subsequences of the given string s and you have to return the whole answer modulo 10 to the power 9 plus 7. Now 10 to the 9 plus 7, you, if you are into CP, so you know this is a prime number, so I won't get into that. Okay, so what you have to do basically is just think it this way. This is basically a DP thing, okay, basically a DP question. So let's say you have, like, since we know that there are only 26 alphabets, 26 letters in our alphabet, so we can have a DP for all the 26 alphabets. I mean all 26 letters, okay? So for all the 26 letters, if we are having a DP, and in each part, so we are going to traverse throughout the whole array. So let's say this is the array, because the array is now not important. All the by array, when I'm telling array, I mean the string, because that is also a character array, okay? So I'm not going to consider what the array or the string is, okay? I'm just traversing from left to right, no matter what. But whenever I'm traversing, I can see one thing, that if there is an element, so for every, like, this is the DP thing, okay? This is the DP, or you may also call it a frequency, or whatever you want to call it, okay? Or whatever you want to call it. You have the freedom to call it whatever you want to. So this corresponds, the first cell corresponds to A, second cell corresponds to B, then C, D, and it goes on. Okay, this goes on. Now whenever you're seeing that there is an element, okay, let's say there is an element A. So I'll just take this condition, okay, ACB. So ACB, so whenever you're having a A, so I can just put the frequency of this as 1, right? The frequency of this becomes 1. Now whenever there is a C, the frequency of this becomes 1, right? But it can also contain A, right? Because it is going to consider all the elements that are lesser than that. Okay, if you think about it as a DP is a thing I haven't even come across yet, just started out coding like 3 weeks ago. No, it's not about like noob coder. Basically, okay, I'll try to explain you DP also in this problem. Okay, I'll try to explain you it in such a manner that you will also understand what DP is basically. Okay, so now whenever you are having a C, so you can either have C alone, or you can have C with A, right? You can have C with A. So that becomes whatever the value of C is, that is 1, plus whatever the value of A is. The value of A is also 1, so it becomes 2. So that is the reason we are getting 2. Okay, now if we are having a B over here, in that case what we can do is B can be singly over there, or B can be taking a value from A also, okay, that is AB. So this also makes it 2. So basically B will be 1, and taking this value from A, it will become 2, right? So in total, how many are there? How many possible subsequences are there? It is going to give us basically for all the alphabets, we can find the sum, because we know that the remaining things are going to be 0 only. Okay. So if we find the sum of this whole DP thing, or whole the frequency thing, it becomes 1 plus 2 plus 2, that is 5. So you can see that the answer is 5 over here, right? But now the question comes, what if ACBAB is there? Okay. So this will make you understand better. Okay. So what was it? ACBAB, right? So what if it is, let me just erase this whole thing out. What if it is ACBAB? Because now the conditions, it is becoming more complex for us to understand, right? It was having just three digits, so it was easier for us to understand. Now for for A, we are going to make it 1 initially. Now when there is a C, as I told you, I am going to take A. So C becomes basically 1 plus 1, that is 2. Okay. And B, it also becomes 2, as I have mentioned in the previous part. Okay. So till this part, it was there in the previous part. Now comes another A. Okay. Now if there is a A over here, so from which element can A draw? So A can draw its alphabet from A only, because it can't draw from C, neither from B, right? Because all of them comes after A, so it can draw only from A. So A is going to draw one from this A also. So A was initially 1, now it becomes another 1. Okay, now it becomes another 1, that is 2, and then it draws one from this previous one. Okay, so let me not write it directly. So A was previously 1, so just for this A, it will contribute 1 to it, also what the previous A was contributing, that is 1. So it becomes 2, and this 2 gets added to 1, that makes it 3. Okay, now whenever we are going to have, so now let me just change the color, because otherwise it will be difficult for you to understand. Now when we are having this B, okay, now when we are having this B, so basically what do we need to check? If there is a or a B before that. Okay, other elements we are not going to consider. So for if is there a or B before that? Yeah, there is a A before that, there is a B before that. Okay, but there are more than one A's, but we don't need to consider more than one A's. We just need to consider what A is contributing and what B is contributing. So what A is contributing 3, B is contributing 2. Okay, now if we add them, that makes it 5, and this B alone is going to contribute 1, that is 6, and earlier B was contributing 2, and if we add 6 to 2, it becomes 8, right? Now if we go for the checking to, now if we go on to check the whole sum, it becomes 3 plus 8 plus 2, that is 13. We can see that the answer is 13. So is this clear? Just tell me, is this clear? So meanwhile, you tell me if this is clear or not. I'll do one thing. I'll go on explaining the code. Okay, so basically I have the length of the string S, and then I'm taking this dp, or the frequency as you may call it, and for every element that I am encountering, I know that it is going to contribute 1 to it, because it is going to, it is going to contribute at least 1 to it, that is this 1. Okay, this 1, whenever we are going to consider that it is contributing 1, and from the remaining it is going to contribute something. So after we have contributed this 1, so we are going to check all the elements which are before that, including that. Okay, S of I minus A gives us the position of this element. Okay, so because S of I, let's say C, and C minus A is basically 2, so we can say it gives us the index of that specific corresponding alphabet. Okay, so till that alphabet we are going to consider all of them, and we are going to add dp of j to it, and this is just a modulus operation. Okay, because you always need to modulo it, because it was given that you have to modulo it. Okay, this modulo thing. After you're done with the whole thing, now you're going to add to that position, you're going to add x and again modulo it. Okay, now after we are done with everything, then we are going to find the answer, which is the sum of all the dp elements. Okay, so if you run them, you can find that it works. Okay, so if this is clear, I will go to the next problem. So this problem, I don't have the code exactly. Okay, I don't have the exact code, because I couldn't complete it within the stipulated amount of time that was given. But one thing that I can do is I can provide you with the logic, because I know like what the logic is basically. Okay, there was some little bit of bug in my code. So is this clear? Shaubhadra, is this clear? Because it's only you who is watching this, so I'm just telling you, is this clear? Yeah, I'll give the intuition. Okay, you're talking about the last problem, right? So I'm just considering he's talking about the last problem. I mean, you're talking about the last problem only. Okay. So find the longest cycle. So what the question is, I won't, yeah, okay. So what the question is, I won't indulge into the question. I won't like read on the question. I'll just explain you what the question tells us, okay? So this is the edges, this is the queries, okay? This is the number of nodes and this is the number of queries, okay? Now using the edges, you can make a tree, okay? You can make a tree. So I don't know whether I can copy this or not. Okay, I can copy this over here. Oops. Now we can see that since we have like made the tree, so this is what the tree will look like. Now in the query that was given, we had to find 4 and 6. So what is the LCA? Okay, so what is LCA? LCA is the lowest common ancestor. So that is the ancestor which is at the lowest value, and it is ancestor to both 4 as well as 6. Okay, so what are the ancestors of 4? The ancestors of 4 are 2 and 1, and for 6 the ancestors are 5, 2 and 1, right? Now what are the common ancestors? It is 2 and 1, and what is lowest? It is 2, right? So 2 is the lowest common ancestor, that is LCA. Okay, so the LCA is going to be 2. Now what we can do is we can like join this LCA with any other node, and you have to find what is the longest cycle that we can get. So if we join this 2 with 3, the cycle is of length 3. Okay, if we join this with this, then also the cycle is of 3. So what is the maximum length of the cycle? It is 3, no matter whether you join it with this or this. Okay, it doesn't matter. So this is clear, right? So what you have to do, so in order, like how you can find the LCA can be found out using what is it called? I think it is called somewhat binary something, right? It's like some filtering. Okay, you have to use some filtering in order to find the LCA. Okay, I can't check it right now. Okay, so using that formula, you can, I mean using that implementation, using that logic, you can find the LCA. Now what is optimal to connect to the LCA? Okay, the optimal is either connecting the leaf node of any other node which doesn't belong to that subtree. So what is the subtree? This is the subtree, right? So we can connect this with any other node which doesn't belong to the subtree connected to the root as well as this. Okay, so that is 3. So we can connect 2 with 3, or it is going to, like, we can connect it with the last node that is connected to that subtree, that is this. Now let's say there was some other nodes like this also. Okay, some other nodes like this. Now it will be better if we would have connected this, right? It will be better if we connect this, right? Then we get the maximum cycle. Now it can be proven that the node that is over there, it has to be connected to any of the leaf nodes, then only we get the maximum cycle. Okay, so it is not like it can be proven, you know the proof what it is. Okay, because then only it will have the maximum possible. Now what is the cycle length? The length of the cycle is basically the depth of this tree plus the depth of this tree, I mean the depth of LCA plus 1, right? So basically, and for this also you can see the depth of this LCA, the depth of this tree plus 1. Okay, so it is basically depth of LCA okay, remember one thing, like if you're working with 0 based indexing or 1 based indexing, so that also like you have to take into consideration. Okay, so basically it is the depth of LCA, that is this depth, because this will always be considered if we are going to take any other node other than the subtree that it is consisting. So that is depth of LCA plus depth, or let's say maximum depth. Okay, maximum depth of all subtrees. Maximum depth of all subtrees from root. Okay, not having, okay, not having the LCA. Okay, not having the LCA. That is, what are the subtrees that is not having the LCA? So this is the subtree that is having the LCA. So I'll just use some other color. I'll just use blue. So this is a subtree that is consisting the LCA. Okay, but this is a subtree which is not having the LCA, and this is also a subtree that is not having the LCA. So basically, from not having the LCA, if we get the depth, the maximum depth of the subtree, so that is going to be 3, right? This is going to be 3 for this. So basically that is going to be 3 plus the depth of LCA, that is 1. Okay, the depth of LCA is 1 plus 1 plus 1. So that is 3 plus 1 plus 1. Okay, now what if we are going to connect this with this only? We have determined that we have to connect this with this. So in that case, that is also simple. It is going to be the depth of subtree with LCA, which is having the LCA. Okay, minus depth of LCA. Minus the depth of LCA. So if we have the length of the whole this thing, so that is basically, what is the depth of this? The depth of this is 1, 2, 3, right? Because this was not there, this I added only. Okay, this I added. Oops, this part I added, right? This blue line I added. So the depth will be 1, 2, 3. That is 3 minus 1, right? Minus 1 plus 1. Why is it plus 1? Because there is this edge that has been added, right? So that is plus 1. Instead of subtracting the depth plus maximum height, we can also do depth plus maximum height. We can also do, yeah, you can do the plus maximum height instead of subtracting the depth. Instead of subtracting the depth of LCA, I don't get you, Shobhadra. I don't get you though. Okay, so this is one condition and this is another condition, and whichever gives us the maximum result. Okay, so plus 1 also, I forgot to write plus 1. So whichever is going to give us a maximum number, we are going to consider it. Okay, whichever is giving the maximum number. So is this clear? This was the last question, right? Yeah, this was the last question. How can I check my rating, like the ranking though? From the summary, I guess, no? Okay, doesn't matter. So my rank is 116, right? So my rank is 116. Yeah. So I'm going to get a negative delta I then. So I will be getting a negative delta. My rating is going to go down today. So is this whole thing clear? Yeah, it is clear. Okay, so it is clear, right? So now people are joining. Now it is showing that the 4 people who has joined. So all the people who have joined, I was just explaining the. Okay, they also left. They also left. Okay, so basically I was explaining. So if you're watching also, so I was explaining the GFG whole thing. Okay, GFG today's contest. So I have done explaining that. So I'll just end the video. So will I end the video, Shobhadra? Should I end the video? Yup. You want to chat a bit? We can chat a bit on like Discord. We can do it. Okay, not over here. You're from which college though, Shobhadra? People who are new to this channel, just subscribe. Okay. Just subscribe and like this video. Okay. Shobhadra, come on Discord. Okay, we'll chat a bit. Come on Discord. So I'll just end the stream. Okay. Previously studied in Scottish Church. Okay, you're from Scottish Church. That's nice. Okay, so I'll just end the video. Okay. Thank you for watching. Okay. Happy coding. Radhe Radhe. Let's end the video.